is the given sample property. So for the one of the things, one estimator class that we have are the moment estimators, where we switch out theoretical moments of the distribution, which is, for example, the expected value or the variance or something, by their sample property, by their sample moment, by the sample moment, which is in this case the average this year. For the variance of the u, it would be this here, which is the mean of the sum of squared residuals, right? So this is the moment, this would be the moment estimator. Like this. One possible moment estimator. And now the question is, how do we calculate this expected value that we need to do some of the steps to actually get to the result that then in the end this thing here is going to be our unbiased estimator. So sigma squared is equal to 1 over n minus k times the sum of ui. The squared residuals, right? So this is the unbiased estimator that we have in the end. I think we need to get there, and we need to kind of understand especially why we not do for normal moment estimators just divide by n, but by n minus k. Okay? And for that, kind of the whole thing that's going on in the beginning here is all for that reason, because we need to know by what we divide the sum of squared residuals to get an unbiased estimator for the variance of the error. So this is why on the first slide they establish a relationship between the residuals and the true error, right? So the residuals and the true error, we get the relationship between them, so that we then can get the relationship between the variance of the residuals and the variance of the true error. Yeah? Yeah?
I have a question. Why is it the true error? Because not so that we have to plug in the u hat is equal to minus x b hat for to get the result. There's like u hat different and true error.
Okay, so this is great. So let me think for a second. So what's happening here in this step? So this is kind of what's going on here. I think this step is the first thing that you need to discuss. Here, we just plugged in the beta hat, right? So this is y minus x times beta hat, which is x prime x inverse x prime y. Okay? So this is where we get this step here. So we just plugged in beta hat. And with the beta hat, now we have y in both steps, and then we can factor it out to get to this point. And now we plug in for y the true model. Right? So now this step is here, plug in y, so that we get mx times x beta plus u, right? So this is y is this thing, and then when we multiply this out, we get mx x beta plus mx u, and mx x is 0, so the first term is gone, and now we're just left with the mxu. And see, this is how we get the relationship between the residuals and then the true error, because residuals are a projection